Good morning to all of you. I am Dr. Surinder Kumar, Assistant Professor of Chemistry, SMSD Government College, Nangal Chaudhary, District Mahendragarh. In last video lecture, we have discussed about Section A gaseous states of BSc first semester Physical Chemistry. Today, in this video lecture, we will discuss about liquid state section B of BSc first semester Physical Chemistry. Introduction. Matter exists in three states. These states are solid, liquid and gaseous. Liquid is intermediate between solid and gas. Liquid may be defined as substances having boiling points higher than room temperature. For example, water, oil. Properties and behavior of liquid will halfway between those of solid and gases. This slide shows schematic representation of three states of matter. The first left portion of slide is gas, while the right portion of slide showing solid. Middle part of slide is liquid. From this diagram, it is clear that interparticle distance is largest in gas molecule while it is least in solid. Interparticle distance between liquid molecule is more than solid but less than gas. These are some general properties of liquids. First property is incompressible nature. Unlike gas molecules, liquid molecules are almost incompressible, mean they cannot compress. Second, indefinite shape. Liquid changes their shape according to the vessel in which these contain. Liquid molecules have indefinite shapes. Third, fixed volume. Liquid has fixed volume. Fourth, fluidity. Liquid always flow from higher level to lower level. Fifth, boiling points above room temperature. All the liquids have boiling point more than room temperature. This property we have discussed in definitions of liquid. Sixth point, random arrangement of particle. The particles of liquid are not in a regular order. They are moving randomly without any particular direction. Seventh point, intermolecular force of attraction between liquid molecule is less than solid but more than gas. Now we will discuss theories of liquid states. There are two main theories which explain the property of liquid. First theory is valency or hole theory. This theory was put forward by Eyring and Ree in 1933. This theory is based upon the fact that liquid is less dense form than the corresponding solid form. The intermolecular space between the molecules of liquid is greater than that of solid. According to Eyring and Lee, the intermolecular space among the liquid is not found to be random but made up of holes or vacancies of size of the molecular diameter. This is the diagram which explain liquid molecule with holes. The blue dots in the test tube is showing fluid, while empty dot is showing holes present in liquid. In this slide, it is clear that liquid molecules are always present with holes. The arrow showing gap or hole present in between liquid molecule, while this small sphere showing liquid molecules. Due to presence of holes, the molecule of liquid can easily jump into them and the switch off gas-like behavior. While those molecules of liquid which do not have any holes in the neighborhood cannot jump and hence show solid-like behavior. Thus, by the use of appropriate mathematical treatment, the mole fraction of solid-like and gas-like molecule can be calculated. From these values, the thermodynamic properties of liquid can be calculated. Eyring and Ree studied on argon and found that the result thus obtained was found to be in close agreement with the experimental values. The second theory is free volume theory of liquid state. According to this theory, the molecules of liquid is surrounded by 10 to 15 neighboring molecules. These neighboring molecules are situated only a small distance away from the molecule. These surrounding molecules form a cage or cell around the central molecule. Thus, the central molecule has to move only small distance to collide with any of its neighboring molecule, but in case of gas, the molecule. Thus, the center or cage can move in small space, that is shown by shaded area in next slide. Thus, the free volume available for a molecule of liquid within which its center can move is called free volume. This is slide showing free molecule in liquid. In this diagram, it is clear that there is a space between two liquid particles. One is central liquid particle, while this central liquid particle is surrounded by number of other liquid particles. And there is always a little space present between the liquid particle that is called free volume. After the theories of liquid, we will discuss a little comparison among solid, liquid, and gases. The first comparison is on the basis of shape. Solid have definite shape while liquid have no definite shape. Like liquid, gases also does not have definite shape. In case of volume, solid have definite volume, liquid also have definite volume, but gases do not have definite volume. Compressibility factor. As we discussed earlier, that solids are non-compressible. Liquid are slightly compressible, but gases are highly compressible. Diffusion. Solid cannot diffuse. Liquid can diffuse but in small extent. Gases can diffuse in other gases. Gases show highest diffusion property among solid, liquid and gas. Solids can diffuse in liquid. Fluidity or rigidity. Solids are rigid. Liquids show fluidity, but they are less rigid than solid. Solid did not show fluidity. Gases show fluidity and gases show fluidity, but these are not rigid. Thank you. Thank you very much.